Hello, I'm Clinton Herget, Solutions Engineer at Snyk. Today we'll be talking about monitoring container images in your production environment with Snyk. In my first two sessions on Snyk Container, we looked at utilizing Snyk to detect, fix, and monitor security issues in your container images from the perspective of the local developer environment and within the build pipeline of your applications. In this session, we'll be concluding this look at Snyk Container by focusing on how to integrate directly with both your container registry and your Kubernetes cluster, and automatically monitor your running production workloads for vulnerabilities inside your container images. Along the way, we'll take one final look at the Secure Container SDLC, but this time from a different perspective, and show how Snyk's developer-first approach can provide value to operations and security teams when it comes to identifying and quickly remediating security issues in workloads that have already been deployed. I'll then show how to integrate Snyk with common container registries, including Docker Hub and Amazon ECR, to provide one-click monitoring of containers after they've been pushed to your registry. We'll take that a step further if you're running in a Kubernetes environment and talk about the advantages of integrating Snyk directly into your production cluster, whether you're running a bare metal or cloud-based Kubernetes platform or on OpenShift. I'll then shift gears a bit from the developer perspective and focus on how Snyk can be utilized by SecOps and IT assurance teams to assess the risk of container vulnerabilities running in production, including how we're able to intelligently prioritize container issues for remediation based on how they're being deployed. And we'll conclude by completing the loop, using Snyk reports to trace a detected production vulnerability back to the development team that introduced it, along with all the context they need in order to remediate as quickly and effectively as possible. In our last two sessions, I've referred a lot to the Secure Container SDLC, but focused on the leftmost parts of the diagram, showing how developers can identify and fix container issues both locally and within the CI/CD pipeline. But of course, operations and maintenance are key parts of the container lifecycle, and Snyk has an important role to play here as well. Vulnerabilities are constantly being discovered, not just when applications are being built and deployed, so continuous monitoring and notifications are necessary even for long-running applications. And this diagram is never a straight line. It's always a continuous loop, because ultimately when vulnerabilities are found in production environments, it's still up to the developers to provide a fix. So even tools utilized by ops teams for continuous monitoring need to contextualize vulnerabilities in terms of the remediation in order to shorten the mean time to fix. Otherwise, developers are put under an additional strain to do more research to identify remediation options, which can create friction, especially in the case of zero-day or high criticality issues. Snyk aims to solve that problem by always giving developers the proper context to remediate vulnerabilities no matter where in the lifecycle they're discovered. It's important to note that unlike some other container security solutions that focus solely on runtime and attempt to identify exploits in progress, by analyzing the behavior of running containers or performing dynamic analysis against application endpoints, Snyk Container remains focused on ensuring the security of the container image itself. That difference actually allows other security solutions to work better, because if Snyk can minimize fix times for CVEs inside images, that increases the signal-to-noise ratio for other potential vulnerabilities, so that runtime tools aren't stuck doing a job they weren't designed for. One way to think about this difference is to consider an airplane. What types of tools enable you as a passenger to take a safe flight? Well, there are two sets of considerations here. First, you need tooling in the cockpit, your altimeter, airspeed gauge, and radar that tell you important things, like whether the plane is about to crash. But you also need to be flying a well-designed aircraft to begin with, and your cockpit gauges aren't very good at telling you that the reason the plane is heading down is because someone left a big hole in the wing. Snyk helps developers ensure that the plane is as safe as possible before it leaves the ground, and quickly identifies the remediation needed when issues are identified in flight. Now, let's take a look at how Snyk can provide those needed protections once applications have been deployed. As you'll recall if you've watched my previous sessions, I've been developing a web application in PHP which I then containerized. In the last session, I showed a Jenkins pipeline which built, tested, and pushed that container image into a registry with a specific tag, specifically Amazon ECR. Now, what if I want to monitor vulnerabilities in this tagged image as it changes over time? Or what if I want to monitor additional images that I may have stored in this registry, such as middleware or third-party images? Snyk supports direct container registry integration with Docker Hub, ECR, Azure Container Registry, and Google Container Registry, as well as Artifactory, with support coming soon for Red Hat's Quay and several others. Onboarding an image from the registry via the Snyk UI can be accomplished in two clicks, once an authentication token has been established. Often the registry is the first place users choose to integrate Snyk container, because the integration is so straightforward and because it's often the single funnel for all container projects within an organization. However, monitoring every single image in a registry can also be a quick way to generate a lot of noise and notification fatigue, especially if an ephemeral tagging schema is employed and hygiene practices aren't always used to keep tags up to date. In general, we recommend onboarding the current version of deployed production applications and keeping Snyk in sync, so to speak, with your tagging schema. Although I'm using the web UI here, it's also straightforward to use our API to programmatically onboard container images from registry to Snyk, which can even be done as part of your continuous deployment process. Now that our image has been onboarded from the registry and scanned, you'll notice one extra feature of Snyk tests in the registry context. In addition to showing vulnerabilities associated with operating system packages, we also provide a test of security issues on any open source application package manifests for interpreted languages found inside the container. In our case, because the image contains a PHP application, Snyk has auto-detected the composer.json file and is providing a Snyk open source test result. So registry integration is an easy way to test your container image and the application it contains all in one. From inside the Snyk UI, you can browse and filter container vulnerabilities, which show similar metadata for each CVE to what we saw earlier on the command line and within the HTML artifact generated by the CI plugin. But this view really shows the power of Snyk's vulnerability database. For example, in addition to CVE severity, we also prioritize Linux vulnerabilities based on the exploit maturity, which means issues that have a known active exploit in the wild are given higher remediation priority than other vulnerabilities, which is a powerful sorting metric when you're talking about applications in production on the public internet. You may recall from our CLI demo that by linking the Docker file that was used to build the image, we were able to offer specific remediation advice pointing directly to the line which introduced the vulnerable package. That's available via the registry integration as well, by providing a link to the Docker file via a Git repository. Once I've linked my image with the appropriate Docker file, I can sort issues based on the layer in which they were introduced, and get the same remediation advice around both user layers and base image upgrade options. So that even for new vulnerabilities discovered in production applications, Snyk still provides value to the developers responsible for making the fix. Another way to give Snyk container visibility into production workloads is to integrate directly with your Kubernetes cluster. While this takes a bit more upfront work to install, it's still a straightforward process and can be utilized even if your container registry is on-premises or resides on a private network. To onboard Kubernetes workflows, our Snyk monitor container must be deployed to your cluster. The easiest way to do this is by using Helm, which is a template-based deployment tool for Kubernetes objects. Simply download the Helm chart for the Snyk Kubernetes monitor and customize a few variables in the values.yaml file, including your Snyk organization ID, and set the permission model. You can either give Snyk visibility into a single namespace, or by using an RBAC role, give read-only access to all namespaces in your cluster. To deploy the container, simply run the helm install command. The Snyk monitor should work seamlessly with any vanilla or bare metal Kubernetes cluster, as well as cloud-based options including EKS, AKS, and GKE. Snyk also supports the OpenShift ecosystem, although the integration is a bit different. If you're using OpenShift, the Snyk monitor is available as an OpenShift operator, which can be added directly to your cluster via the Red Hat Marketplace. No additional configuration is needed. Once the monitor is deployed and the service is running, you'll be able to onboard your Kubernetes workloads to Snyk. Again, you could do this manually via the web GUI or make the request programmatically via the Snyk API. But there's one additional option here, which is to indicate within your deployment itself that you want the images to be monitored in Snyk. This is done via an annotation, which is a piece of metadata associated with any Kubernetes object. Simply add the annotation to your deployment YAML file and apply it as you normally would via the kubectl command. Then these workloads will automatically appear as new Snyk projects without needing to manually integrate them. Beyond giving Snyk container vulnerability results for images deployed to your workloads, similar to the registry and other integrations, Snyk can also show you important runtime signals directly from the Kubernetes API about configuration details, including whether your workloads have proper resource limits set, whether deployments are running in privileged mode, and more. It's important to take note of these signals, both for their own sake and also because they affect the blast radius of underlying vulnerabilities within your container images. As you likely have already seen on previous demos, for each vulnerability we discover, Snyk assigns a priority score, which takes into account the underlying severity as well as things like the exploit maturity, whether a fix is available, how recently the vulnerability was discovered, and so on. This score is designed to give you a sense of the highest risk issues when deciding what to remediate first. But for Kubernetes projects, we're able to offer an additional layer of context that takes those runtime signals into account when prioritizing your container issues. So for example, if you have a container vulnerability which has a privilege escalation attack vector in the CVE, meaning that a remote exploit could gain the permissions of the container running the application, we're going to prioritize that vulnerability higher when it's running in a workload that doesn't have a non-root user specified, because that means the blast radius of the vulnerability is potentially much larger in the context of that specific deployment than it otherwise would be. So don't be surprised if vulnerabilities are prioritized a bit differently in Kubernetes-based integrations versus looking at the same image at other points in your SDLC. Of course, these Kubernetes runtime signals are ultimately security issues in their own right and should be remediated. Fortunately, Snyk has a solution here as well, because in addition to container and open source vulnerabilities, we can now also test for common configuration issues within infrastructure as code files, such as Kubernetes deployment configurations, all within the developer workflow before those files are ever deployed to production infrastructure. Be sure to check out our other demos which focus on Snyk's IAC solutions. Now that we have all of our production workloads actively monitored in Snyk, let's pull it all together and walk through a typical use case from the ops or security perspective, showing how container vulnerabilities can be detected and ultimately traced back to the development team for remediation. Using Snyk's reports interface, I'm able to get a top-down view of all vulnerabilities associated with every project in my organization, which I can filter by ecosystem to show only container-based issues. I can also search for a specific CVE or a specific dependency, so if there's a zero-day vulnerability or I want to test my production workloads for a specific issue, I have a single pane of glass. I can also sort by the highest priority issues across all of my projects, taking into account all of the variables we've talked about previously, including exploit maturity and blast radius, with the easy ability to drill down into a particular CVE to identify the projects which contain it, regardless of whether they were onboarded via container registry, Kubernetes, CLI, or some other integration. Snyk also offers the ability to associate an owner with each project, as well as project attributes and tags to keep projects neatly organized and identify the parties responsible for remediation. And remember, all projects are retested daily, so that if a new vulnerability is discovered, you'll be instantly notified. No matter where the project originated, vulnerabilities are always packaged along with actionable remediation advice in a context that developers can understand and consume, because ultimately they're the ones responsible for fixing issues within container images. Snyk isn't about providing a big list of problems, but rather about identifying solutions and streamlining communications between security, operations, and development teams, who all ultimately share the same goal: more secure applications in production. I hope you've enjoyed today's talk about securing your container images in production with Snyk. If you haven't already, I encourage you to check out my previous 2 sessions on using Snyk in the local container build environment, as well as within the CI/CD pipeline. I hope you enjoy the rest of SnykCon. Thanks again, and as always, stay secure.